Hello friends, myself Mansoor Maulavi. This is my fifth lecture over the topic lipid. In first lecture, we had seen about the definition, function and the classification of the lipids. Then for next three lectures, we had seen the detailed classification of each type of the lipids. This is my fifth lecture over the reactions of the lipids. Before starting this topic, if you like my videos, then I'm requesting you please subscribe my channel and comment. Let us start about the reactions of lipids. Lipids shows different types of chemical reactions, and these chemical reactions are the saponification, hydrolysis, emulsification, and the rancidity. One by one, we will cover and understand the chemical reactions of the lipid. First is the saponification reaction of the lipid. The saponification reaction of the lipid refers to the formation of soap from the fats and oils using the alkalis. So, the alkaline hydrolysis of fats and oils produces the the soap, that is salt of fatty acid and the glycerol, and this chemical reaction is known as the saponification. So here the role of the fats and oils with the alkali is important for formation of soap. This is the chemical reaction which represent the saponification reaction of the lipid. So this is the triglycerides which shows three esters functional group in the fats and the oil. It reacts with 3 mole of the alkali like sodium hydroxide. It undergoes hydrolysis at 3 parts to produce 3 molecule of the soap, that is the salt of fatty acid and the glycerol. So because of this formation of soap, this reaction has the industrial significance. So saponification reaction is used on the industrial scale for formation of the soap using the different types of fats and oils and the alkalis. But for formation of good quality of soap, it is very important to find the saponification number of fat or oil. So let us look at the different types of soaps. Depending on the sources of the fats and oil and alkalis used for the formation of soap, that is for saponification reaction, the soaps are of different types. From their generic name, like chemical name, we are looking the soaps. Sodium soap. Sodium soaps are also known as the hard soap. These are also known as the soda soaps. Sodium stearate is the chemical name of soap. So from the name, the stearic acid and the sodium hydroxide is used for the formation of such type of soap, and it is used in the personal care products. Potassium soap. Potassium soaps are known as the soft soap, and these are available in market in the paste. Potassium oleate is a chemical name for potassium soap. As name suggests, the oleic acid and the potassium hydroxide is used for the formation of such soaps. These soaps are widely used for our personal care products. Other than this, the calcium soap, aluminum soap, lithium soap, ammonium soap, then zinc soap, magnesium soap, these soaps are used on industrial care for the different types of purposes like lubrication, emulsifying agents, for formation of talcum powder and the other. So the soaps are important for our life, and it is very important to note that the fats, oil and the alkali are used for the formation of soap through the saponification reaction. Let us move to another chemical reaction of the lipid, that is the hydrolysis. Hydrolysis refers to the reaction of water with the ester to form the acid, fatty acid and the alcohol. So in ester, the both functional group are present. The fats and oils are the triesters, which are also known as the triglyceride. It undergoes the hydrolysis with the enzyme lipase to produce the glycerol and the three molecules of the fatty acid. If we differentiate this reaction from the alkaline hydrolysis, in alkaline hydrolysis, we get the salt of the fatty acid, that is the soap, but in hydrolysis reaction, we get the free fatty acids. So hydrolysis of the triglycerides with acid or enzyme lipase produces the glycerol and the three molecules of free fatty acid. This reaction is the acid hydrolysis or hydrolysis of the triglyceride. This is the reaction. This is the triglyceride. This triglyceride undergoes the hydrolysis using the enzyme lipase at 3 points to produce the glycerol and the free fatty acid. So the acid hydrolysis is very fast reaction. In one step, it produces the glycerol and the three molecules of the fatty acid. While the enzymatic hydrolysis is a stepwise reaction, slow reaction. It produces the it take place in the stepwise manner and important in digestion of lipid in our gastrointestinal tract of the body. Third reaction is the emulsification reaction. Emulsification is a process in which the lipid mass is converted into the number of small droplets that the globules, and after that it increases the surface area of the lipid, so it is easy for the digestion. So this is a larger mass of the lipids in our stomach, and after emulsification it is broken down into the smaller droplets or globules. So this process helps for digestion of fats into fatty acid and the glycerol, and these are easily absorbed by the small intestine. So it is emulsification is very useful for the digestion of the lipid material in our stomach. Let us move towards fourth reaction, that is the rancidity. So rancidity of the lipid material of the food material refers to the spoilage or the degradation of the fats or oils, resulting into the of flavors and odors, and sometimes changes the texture of the color of the food material. So the rancidity is nothing but the chemical change happening in the fatty food material, and these chemical chains are primarily the oxidation and the hydrolysis. So depending on the chemical change happening in the lipid, that is the rancidity, are of two types. First type is the hydrolytic rancidity and second type is the oxidative rancidity. So reason for the hydrolytic rancidity is the hydrolysis of fats in the food material by the bacterial enzyme lipase, while the oxidative rancidity of the food material is due to the oxidation of food material by air, light, oxidant, moisture, and at the high temperature. So with this knowledge of the rancidity, we will cover the difference between the hydrolytic rancidity and the oxidative rancidity. Hydrolytic rancidity, the water is important for the spoilage of the food material. But in oxidative rancidity, it requires oxygen or air for spoilage of the food material. The hydrolytic rancidity occurs due to the partial or complete hydrolysis of lipids by the bacterial enzyme lipase. So addition of water to the lipid molecule is a hydrolysis, but this reaction is catalyzed by the enzyme lipase. The oxidative rancidity is occurs due to the oxidation of the unsaturated fatty acid in the lipid by the air, light, oxidant, moisture, and the high temperature. The hydrolytic rancidity produces the glycerol and the fatty acid, while the oxidative rancidity of the food material produces the different organic compounds like carboxylic acid, aldehyde, ketones, etc. Some products are volatile, while some to avoid the hydrolytic rancidity, the fats are protected by using the refrigeration and the drying of the food material. To protect the food material from oxidative rancidity, the fats and the food materials are protected by using the addition of the antioxidant chemicals like NDGA and the BHA chemicals. This is the example of food material. that shows the respective type of rancidity. In case of the butter, butter is a fat concentrated. So in butter, there huge amount of the fats are present. Fresh butter shows the sweet and the creamy smell, while the rancid butter show the foul smell. In case of the oxidative rancidity, generally the edible oil undergoes the oxidative rancidity. The fresh oils are lighter in color, while the rancid oils are the dark in color. So the rancidity of the fatty food materials are related with our health issues. If we conserve the rancid food material, then we can suffer from the large number of diseases included the stomach problem and the so the knowledge of chemical reactions of lipid is very important in the food science because lipids are integral part of our diet, and these lipids are useful for the energy sources for our body.